I hope you guys are getting anxious to move on into some new material. So we still have some more review here. We're going to look at lines and the slope and then how to write the equations of lines. So if any of this, if you're a little bit shaky on any of this, please, you've got to do extra work. There are more examples in the textbook than the ones that I'm going to show you here. I just want to kind of run through some stuff fairly fast. If you know this inside and out, then please feel free to fast forward through it and just kind of look occasionally, make sure that you're getting everything that you need. But I think probably most of you are about at that point there that you know all this stuff quite well. Well, let's take a look. Then this is section 1.3. And my PowerPoint will not open up, so we're just going to write it out. It says there's an error. So this is on lines and slope. Mostly slope and writing the equations of lines. All right, well, let me see next. We have several different forms for lines. We have standard form. Standard form looks like this. AX plus BY is equal to C. But you have to make sure that the A, B, and C are all integers, and then also that the A has to be a positive, so that coefficient of the X also positive. Then we also have slope-intercept form. And that is y is equal to mx plus b. And our last one is point slope. And that one, of course, is handy when you have given a point and the slope. Then you can just plug it into that. So point slope form is y1 minus y2 is equal to the slope times the difference in the x's. All right, so we have those three different forms that we work with. Let's take a look at slope as a ratio. So this is going to be kind of annoying to watch me write all of this out. But let's say that maybe you've seen in the mountains where they have trucks, be sure to check your brakes as the grade of the road over the next 11 miles is 7%. So let's see what the change in elevation over those 11 miles would be. So here we're thinking of the slope as a ratio. So it tells us that the grade is 7% over the next 11 miles. So over what we're going to do then is set up the slope as a ratio. So the ratio is going to be 7 over 100 for 7%. And we want to look at the ratio then. We're going 11 miles, and we want to know what the drop in the altitude is going to be, the height there. Okay, so we would cross multiply. Oh, but I forgot my x when I cross multiplied. And then divide by 100, so 0.77. So we're going about 0.8 of a mile then in height as we're going 11 miles forward. Okay, so there we're looking at slope as a ratio. We can also think of slope as a rate of change. So maybe we have a manufacturing company that determines that the total cost of producing some product, so the units of a product is equal to maybe $5,280 plus 17x. Okay, so given this cost function, how would you interpret the slope and the y-intercept in the context of the problem? Well, the slope is going to be the 17, and since we're taking every unit that they produce times 17, then 17 is going to represent how much it costs to produce that unit. So our slope is the production cost. So for every additional unit we manufacture, it costs us another $17. Whereas the y-intercept, the 5,280, is what it would cost if we didn't produce any units at all. So if this is 0, so then that means that was our setup charge. That's how much it cost us to get everything that we needed. Okay. In finding the slope of a line or between 2 points, and let's just say we have the points 319 and 527. So to find the slope there, we can look at the change in the y over the change in the x. So the change in the y going from 19 up to 27, we are going up 8. And on the x, we're going from 3 to 5, so we're going up 2. Oh, there's that phone again. So we end up with 4 for the slope of that line. Now, if we want to write the equation of a line, let's say that we know that the slope is 3, and we want the line with that slope, and we want it to go through the point 2, -3. So this is a perfect time to use the point slope form because we're given the slope and a point. So the point slope form, y1 minus y2 is equal to the slope times x1 minus x2. Okay, so what we do is we substitute in the point for this x and this y, and then we put the slope in here, and then we'll just drop off those little subscripts on the y and the x. So we'll go y minus -3, so y plus 3 is equal to 3 times x minus 2. Okay, let's go ahead and rewrite that and put it in standard form. So we distribute the 3. Because I want the x term to be positive, I'm going to move the y over here. So I've got a positive 3x now. Yikes, I don't want that, do I? I want minus y is equal to, so then I will add the 6 over to the other side. So it's equal to 9. So there we have the equation of a line in standard form with the slope of 3 and a y-intercept and going through the point 2, -3. Remember perpendicular lines and parallel lines? Oops, I got to go to another page. Here we go. So if I have a slope, and let's say just the slope is m, then the slope of any line parallel to a line with the slope of m is going to be the same thing. Whereas the slope of a line perpendicular to a line with the slope of m is going to be the negative reciprocal of m. So let's take the equation 3x minus 2y is equal to 6. And we want to write the equation of the line perpendicular to this line. And then we want it to go through the point 3, -5. All right. So the first thing we're going to do is find the slope of our line. So because it's in standard form, the slope is the opposite of a over b, so we get 3/2 for the slope. So for the slope of a perpendicular then, the negative reciprocal is -2/3. This time, yes, I'm given the slope and a point, but this time I think I'll use slope-intercept form. So y is equal to mx plus b, so to write the equation of a line, we need the slope and the y-intercept, those two things. So we have the slope. We're looking for the b value then. We don't know what the y-intercept. So that means that we have to substitute in for an x and a y, and that's what we were given up here with that other point. So I put the -5 over here, put the 3 here. -2/3 of 3 is -2. So that means then that the y-intercept will be -3. So the equation of the line in slope-intercept form is y is equal to -2/3 x minus 5. All right. This year, we just got an email from Margie in counseling, and she said that Windsor High School student population this year, so we've got 2009, our student population is 1,086. Okay, that was supposed to be a semicolon. Sorry. I'm not picking up my pen, I guess. And last year, our student population, I can't remember for sure, but it was somewhere close to this, I believe. Okay, so what we want to do is, with that information, let's say that we have a linear regression here. So it's going up linearly, so we have the same change every year. We gain about the same number of kids. So we want to figure out then what our student population is going to be in the year 2011. Okay, so 2 years from now. All right, so we can use the slope then to help us with this. So we can think of these as ordered pairs. In fact, I'm just going to go ahead and put them in a little table here. So we have x, y. So in the year 2008, we had 1,048 students. This year, 1,086. Okay, so for our change in y then, well, from 1,048 to 1,086 then, we're going up from 50. 48 to 50 is 2. 50 to 86 is 36. So we're going up 38 students. And the change in the x is 1. So change in y over change in x, which represents the slope, is 38. Okay. So if we start off with this year's population then, so we have 1,086 right now, and then 2 years down the road, if we're adding approximately 38 kids a year, we can multiply. 38 times 2 is 76. And then add that on. We could possibly have a population of 1,162 students. Okay, so hopefully that wasn't too boring. If it is boring, then that means that you guys really know this stuff, and that's a good thing. And very soon, in a couple of more sections, we're going to be going on and doing some new stuff. We'll finally get to do some work with limits here in a little bit. All right, so in the meantime, thanks for bearing with me, and thanks for working hard on all of our review.